Hello, everybody. My name is Erdinc Senol, and I am the co-founder of Raw Mobility. First, the introduction to our company, what we are doing. Here at Raw Mobility, we are working on indoor and urban mobility services. And our target is to make these services safer and more efficient through digitization and autonomy. Raw Mobility has been established with more than 30 years of academia and industry experience in total. Following his PhD in robotics, Ahmetcan had research studies on smart wheelchairs in Northwestern University. After that, he had technical leader roles in a global autonomous driving company. And with his broad technical knowledge and experience, Ahmetcan is leading the technology side of Raw Mobility. And I have spent more than 15 years, first in Russia as an expat, and after that in Germany and Turkey, in power plants, gas terminals, and in data center industries. Skills I have developed within these years on team and operations management, I am responsible on operations and business side of the company. Okay, if you look at the mobility, what's the term of mobility? Different definition, direct definition of mobility is ability to move or to be moved, but it is still dependent on a technology built centuries ago in our society. And our today's technology is still not used in most of the mobility services. And as Raw Mobility, we have the vision of using the AI algorithms on our real-time image process data to reach a safer and more efficient mobility system by avoiding crashes and reducing the number of accidents. And our plug-and-play edge intelligence can be retrofitted to function as a central nervous system to any micro-mobility system, as well as indoor transportation vehicles. In the light of this target, we have completed our first technology validation of our product. We named it Safe Walk, and completed our field tests and showed that we can avoid crashes with our real-time image processing and AI algorithms. With the integration of AI planning with route optimization and scheduling, we will transform the mobility as safer and more effective services. And why we have applied to AIPlan4EU? As I tried to mention, we are aiming to reach a mobility 2.0 system. From this definition, what we mean is taking human effort out of the equation and avoid human error. So we are imagining a mobility service where it is impossible to crash and perfectly scheduled according to demands. In our case, AIPlan4EU and planning algorithm is a great complement for this ultimate goal. With that in mind, we have sent our use case detailing the planning needs on indoor mobility services and indoor person transportation, especially in large complexes like huge airports, is still not optimized due to the complexity of vehicle types, the destination request, timetables, and continuous alterations, real-time alterations. If you look at the mobility services being used at the airports now, in large airports, there are buggy services, personal wheelchair services, and very recently and rarely used e-scooters are available to meet this transportation demands in terminals. Each of these services have different passenger capacity and capability, of course. While e-scooters can be used for personal and light transportation, buggy services can serve families with luggages. On the other hand, wheelchairs are for elderly and disabled passengers. But indoor mobility services are becoming more and more important with longer walking distances as the airports are becoming larger and larger. And walking distances is one of the most important index for the airport service quality. In some of the airports, these distances can take for passengers more than half an hour, as it is mostly not possible to minimize these distances to be covered. A safer, more effective, and commonly used mobility service is crucial to increase service quality of the airports. Now we can see our focus use case location, Istanbul Airport, and how mobility issues are managed. Istanbul Airport has the biggest terminal with approximately 1.5 million square meters, and you need to walk long distances, both for arrivals and departures. Mainly buggy services are used to cover these walking distances, but you can only book and take buggies from certain locations where you need to walk them. And at that locations, you have to interact with the service personnel, and the reservation is done manually without any optimization. Following that, you will be driven by a service personnel again to your requested destination. With around 50 million passengers yearly, it's not possible to meet the demand of terminal passenger transportation with the mobility system used, existing mobility systems, manually operated and manually scheduled. It's a fact that in our use case location in Istanbul Airport, a widely serviceable mobility system which requires minimum service personnel and can operate automatically with maximum efficiency need to be in service. And there are mainly 4 shortcomings causing complaints of the current services. Buggy service points, as we have seen and touched on, are in predefined locations, and passengers need to walk long distances to these locations. And other mobility service wheelchairs are only for passengers with special needs and requires a dedicated personnel. E-scooters, which are very recently being used and rarely used, are generally used by younger passengers with no or light luggage, and they are not integrated to other mobility services. Sorry. And finally, reservation is done manually in predefined locations by additional personnel with no scheduling. If we try to go in detail with an example use case, 2 different passengers booking buggy service, either together with his or her flight ticket, or before his flight, or even during his or her flight, through an app or web interface. Planning algorithm matches the flight details of these passengers and schedules the correct buggy type to be at the correct arrival gate and takes them to pass control. Currently, current operations, you need to walk most of the distance to the buggy service points and take the buggy. And in this case, there will be 2 separate buggies will operate with 2 dedicated service personnel, which is not effective at all. If you look at a bit more complex example for a departure scenario, let's say 6 passengers request buggy services to gate A150 and 1 passenger to gate A100. And the maximum capacity of the vehicle buggy is 4 passengers. Planning algorithm issues a buggy for the 4 of the 6 people directly and drops them off the gate. And planning algorithm matches 2 remaining requests of 2 passengers to gate A150 and a single passenger to gate A100 and assigns a buggy for them. Buggy takes all 3 passengers and first it drops the single passenger to gate A100 and proceeds to gate A150 and completes the route. In current scenario, in existing operations with manual services, in best case scenario, more than 3 vehicles would have to be in operation with more than 3 service personnel. So isn't there any alternative solution for the current shortcomings? Yes, but for the availability and to make it widely serviceable, airport operations need to increase the service personnel and number of buggies, which will end up with enormously increased cost and still with low passenger satisfaction. Also, with increased fleet and personnel, it will be chaotic to schedule the services, and this will create even more ineffective services. But with planning and digitized buggies, airport operations will be able to reach a mobility service which has a great utilization factor and high passenger satisfaction. And how the planning will be applied? First of all, the flight and passenger data, including all timetables, real-time tables, need to be accessed from the airport operations. Also, localization of buggies inside the terminal need to be monitored in real time. According to these data, together with passenger requests through, as mentioned, through an app or a web interface, planning algorithm will decide how many vehicles, which type, and where to be sent. Airport operations will then have the option of tuning the maximum wait times for each passenger and also maximum stops considering the airport service quality criteria and cost of the operations. And how frequent the planning will be running. Planning will be triggered whenever a new user request is in and in case of emergencies and layout changes. Inputs, planning algorithm will need following inputs to correctly function. The number of passengers and their destination requests, together with their special needs, if there is any. The fleet informations, such as how many vehicles are available and their battery levels. And finally, the map of the environment. With all that inputs available, planning algorithm will decide on the type of the vehicle to be utilized, the optimized route, charging interval of vehicles, and finally, operation intervals for traffic and passenger wait time optimization. In order to show the efficiency of planning algorithm with metrics, we will be following the change in battery consumption, idle vehicle time, distance driven per passenger, which in total improves the lifetime of buggies together with predictive maintenance, and of course, passenger satisfaction and overall mobility operation costs. Through these KPIs, we want to track the following value propositions of the planning algorithm: increased fleet efficiency, energy saving, reduced traffic, decreased operation costs, improved passenger satisfaction, and increased revenue because there will be an increase on demand for this new mobility system. In addition to these value propositions, we are aiming also several societal impacts with this new system. There are less CO2 footprint with reduced traffic, less idle use of vehicles, and improved charging cycles, and positive community effects by improving the capacity of motion of elderly and disabled citizens to be more involved in the workforce and recreational travels. So that's all from our side. Thank you for listening.